So this is the 8th session on the topic of music through Matlab. And what we are going to study in this session is how to graphically represent the rhythmic and the pitch patterns. In our last session we had said that melodies can be differentiated from each other by their different rhythmic patterns and different pitch patterns. Now, to some extent the rhythmic patterns we have studied, at least the basics of rhythm patterns we have studied in the last session. But before going on to study the pitch patterns themselves, we would first like to see how to graphically represent both the pitch patterns and the rhythm patterns. And in our next session, we shall study the pitch patterns themselves. Alright, so let us start. So as we said, melodies contain various pitch patterns, also called as pitch contours. And pitch patterns tell us how the frequencies of various notes are changing as the melody progresses. And what we would like to do is to graphically represent the pitch patterns as well as the rhythmic patterns. Now, in order to be able to do so, we need to make a small change in our note function. Note function has to be modified. So the change that we make is that we add one variable to the output variables. Previously only the note vector was returned. Now the frequency of the note also will be returned. So let us see the modified note function. First of all, note that we have now changed the name of the note function. So that was note G4. We have now made it note G5. The input variables remain same, S, N and D. Remember, S is for saptak, N is for note number and D is for the duration of the note. Now previously in the output we only had the tone vector, but now F1, that is the frequency of this note, is also returned. Remember that F equal to 130, in this case this is our reference frequency, it could be something else. But then the frequency of the note itself is obtained by multiplying the reference frequency by capital N, where N is calculated based on S and N, that we have already studied. The rest of the statements are similar to the previous note functions, but now what we are doing, we are also returning F1 to the output. So that is written on the left hand side here. So only first line is different, really speaking. Now what we are going to do to demonstrate how to graphically plot the pitch patterns and the rhythmic patterns, we'll take an example. So let us take a 4-phrase melody, a very simple melody. X1 is one phrase, X2 is another, then we repeat it, we repeat X1 and then we repeat X2. So X1 is like this, S, R, G2, which means S is 1 matra, R is 1 matra and G is 2 matras. Suffix of 2 says that. This is repeated, then you have got 4 notes of 1 matra each and finally you have shadaj of 4 matras. Then for X2 you require S, half note of S, so that is, this is shadaj having duration of half the matra. This is repeated, then you also require rishabh having the duration of half the matra. Similarly, the other notes are put in this sequence. And finally, this is the final sequence that is generated. Alright. So in order to code this melody, we need to generate all these notes. So let's see how they are generated. So first of all, we define our durations. D is equal to 0.4 second. That is the reference duration. It could be something else also, but in this example we have taken D equal to 0.4. D2 is double that, so 2 times D. D4 is 4 times that, 4 times D, and DH is half of that, so that is 0.5 D. So using these various durations, we can generate notes of varying durations. For example, the first one, you generate shadaj of 1 matra, so you provide only D here, and 2 and 0 of course specify that it is the shadaj, and Fs is the return frequency. Then you generate SH by using DH. Remember, DH was 0.5 D. Of course, although the duration is halved, the frequency remains same. So here we have got Fs and here also we have got Fs. Similarly, we generate S2, S4 and all the remaining notes are generated in the similar fashion. And once these notes are generated, then we are now ready to write the code for generating the melody and the pitch patterns as well as the rhythmic patterns. So let's see how to do it. So let us first start with the first musical phrase, that is SRG2, SRG2, SRGR and S4. Now what we do, we define a F1 vector and this contains a number of frequencies. However, these frequencies correspond to those notes which have 1 matra duration. So we have called it as say F1. So S has the frequency Fs, so we write Fs here. R has the frequency Fr, so we write Fr here. But now this note is of 2 matra duration, so we write 0 here because F1 contains only those frequencies whose notes have 1 matra only. So again SFS, RFR, for G2 we write 0, SRGR all are 1 matra, so we write Fs, Fr, Fg, Fr, and this is 4 matra, so we write 0 here. Then F2 contains those frequencies whose notes are double duration. All the rest of the for the rest of the positions we write 0. So here you see that this Gandhar is double duration, so we write Fg here. This Gandhar is double duration, so we write Fg, and in all other entries we have got 0. And finally we have F3, which represents the note of 4 matras and there is a single note here, that is S4. So all the first entries are zeros and then you have Fs. Okay. But why we are doing all this? It will become clear as we go along. So first we say subplot 211. This is because we are going to plot not only the first phrase, but we are also going to plot the second phrase, that is X2, that is in the next slide. So we say subplot 211, then plot F1, stem F1, color blue. Why we do that? Because we want to use color coding for showing durations. So in this case we are assuming that blue represents 1 matra. Line width of course depends on how thick your line you want it to be. So based on that you write the 1.5 is a reasonable value. Alright. Now you write hold on. Why do you write hold on? Because on the same plot you also want to plot F2. So on the same plot when you plot F2, what will happen? These Fs and Fr are retained. So although there is 0 for F2 here, on the same plot this is of course visible. But now here it was 0, but here it is Fg. So that Fg will now be visible. So the point of hold on is that you are plotting all the graphs on the same plot. So after plotting F2, you again say hold on and plot F3 also. And then you have this grid on, title, X label, Y label that we have studied before. Okay. So this will essentially give you stem plots in which the y-axis is calibrated in terms of frequencies of notes. The x-axis shows the note number. When I say note number, don't confuse it with small n. Small n was specified for generating a specific note. Here when we say note number, we are talking about the note number in the melody, first note, second note, third note and so on. Alright. So this is for plotting for the first phrase. Similar code you have to write for the second phrase. So this is again very similar, so I am not explaining it. And when this is executed, you will be able to see the plots. So you can see this on the x-axis we have note number, the first note, second note, third note, fourth note and so on. On the y-axis we have the frequency. So this is the frequency of the Shadaj, which in our case was 260. So it is showing 260 here. Now this is 1 matra, this is 1 matra and this is 2 matra. So note that the height shows the frequency, height shows the pitch and the color shows the duration. That is our convention here. You could have used some different colors for different matra, but you have to choose something, and in this case I have chosen blue for 1 matra, red for 2 matras. So you have SRG2, so 112, again repeated 112. Then you have 4 notes of 1 matra duration, so 1 1 1 1, followed by a note of 4 matras. So that is plotted in green. So green corresponds to 4 matras, red corresponds to 2 matras and blue corresponds to 1 matra. and the height of course corresponds to the frequency. So the y-axis is calibrated in terms of frequency. This is phrase 2. Now in phrase 2 we have half matra duration notes. So we need a different color. So we have used cyan here. So this is half matra, half matra. In fact, we have got 4 notes of half matra duration. So it looks like this: half, 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 half. Then 1, 1. Then 2, 2. Then again half, 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 half. You can see here. And then 1, 1, and finally 4. So this gives you an idea as to how to plot the rhythmic and the pitch patterns on the same graph. Of course, for different phrases, we have plotted 2 different plots. Alright. So let's see how the melody sounds. Alright, so this should give you some idea as to how to write the program for generating rhythm and pitch patterns, graphs for generating rhythm and pitch patterns. And that's all in this session.